see if it's ringing. Uh-oh. How you doing?
Good.
Okay, I'm gonna start soon. I'm just trying to. How's everybody doing? Let's see who's online right now. How many people are watching it? 4 people. Okay, that's good. Let's see. How we doing? How's the day going for everybody? Can you hear me? Hello? Oh, there we go. 1 second, I'm trying to. There we go. All right, so we got Nicole, Eric, Hunter, Chloe, Sabine's here. Good, good. Now, remember, okay, take a look. Let me enlarge this here. Let's put this over here. And let's enlarge this so people could see that we got to finish this. This is we're going to go over questions. Okay. That's okay. You could wake up a little later now, but you got to be responsible. Okay. Take a look. I'm looking at this assignment here, this progress here, and I got 7 people that haven't done it yet. 3 people are still doing it, whatever that means. Okay, but I got 7 people that haven't done it yet, so you got to work through this. Okay, so make sure you go through this. And right now, what we're going to use today is to see who has questions. Now, first of all, remember, okay, there's a lot of change going on. A lot of stuff is happening here. Don't get all stressed out about it. Okay, we're going to work on these problems. We're going to get better. Just keep reviewing all these problems and stuff like that. That's the plan. Close the iPad. The plan is to keep reviewing these and see what is that. How's that sound? Does that sound okay? Because it seems like let me change it just so. All right, so we're going to keep reviewing these, and then we're going to do that too. There we go. We'll keep reviewing, and we'll just keep going over the ones people have questions on. And so you got to do them, and you got to know what you have questions on and what you don't have questions on. Okay? So I know this is a whole different change. It'd be great if we were sitting in the room and I was seeing you guys and everything was working okay, but this is what it is. And the AP test is a little lighter. I'm talking to people, some of the big shots on AP, and I'm starting to get a feel for what type of questions. I'm putting my own suggestions in and stuff like that, like the bathtub type problems. I bet there's going to be one of those on there, and we'll talk some more about this kind of stuff. Hey, look who's here. Hi, everybody. Say hi.
Hi.
Here, talk to my phone. Say hi.
Hi.
This is my class. You're in my class now, too. How is your writing?
I was wondering if I should, because it says the green light flash. Should I place like an exclamation mark?
Sure, if you want.
Okay.
That'd be good.
Bye.
Yep, I got to teach him. He's earning diamonds right now because you got to be successful. Okay, so yeah, and I think what Alex is saying, I think they're going to be free responses. They're not going to be multiple choices. But the nice part about multiple choices is we cover a lot of different choices. So first of all, while we're here, now remember, this is due on Monday. I'm going to record it in the grade book. Okay, so whatever everybody finished, and then we'll still double check on Monday, and then there'll be another one on Tuesday. So we'll do today, and then you could finish it up tomorrow. And then on Tuesday, well, you get the weekend. You can work on whatever you want to work on. But I want to go over the ones that people have questions on. Okay? So let me pull them up here. And which one? Open up. Let's see which ones we want to do. Anybody have a suggestion? Maybe we want to go. And okay, what I also did is number one, I also put online. For some reason, sometimes I could print out the test. Sometimes I can't print out the test. Okay, so on the first one, I was able to print out the answer document. Okay, so it's like 23 pages or 25 pages or something like that. So if you look on Schoology, the answers to this assignment is up there. Okay, so after you finish one, it has how it's graded, and the format's not the best, but you probably could figure out how it's going to be graded and what things are going on and how it's working. So let's talk about, Eric said number 1. Let's look at number 1 here. Now, I think there's a typo on number 1, to be honest with you. Take a look at, that's the wrong one. Wrong computer. Take a look at number 1 here. Okay, we got f is a twice differentiable function. So f of 2 equals 5 and f of 5 equals 2. G is the function. Okay, explain why there must be a value between 2 and 5. Okay, explain why there must be a value between 2 and 5. Okay, such that f, I think they're saying f prime. Okay, f prime of c equals -1. Okay, so let's go with this as saying f prime of c. Okay, that's number one. Okay, so take a look at what we got here. We have values of f, and they're asking about f prime. Okay, we have values of f, and they're asking about f prime. Right away, what should we be thinking now? Okay, so what should we be thinking? As I write this out, we got f of 5 equals 2, f of 2 equals 5, and they want prove to me, guarantee f prime of c, there's some value c that's equal to -1. That's, I think, is what the problem should be talking about. Okay, so first of all, does everybody see the mean value theorem? Okay, now, like I said, open notes. So do you have in front of you the mean value theorem? Okay, you should be saying, since f is both continuous and differentiable. So this should be just automatic. This should be automatically starting up. Since f is both continuous and differentiable by the mean value theorem. All right, now what should we say in the mean value theorem? F prime of c, that's the first part, the instantaneous rate of change, must equal the average rate of change. Let's do it. F of 5 minus f of 2 over 5 minus 2. You see, for some c where c is between 2 and 5. Okay, that should just be automatically, there's the whole thing that should just be automatically written right away. Since we know we're talking about 5 and 2, and we're looking for c, well, not looking for c, but we're looking for the derivative, the mean value theorem comes to mind right away. This should be just automatically written down. That should be just look like exactly what your notes should look like. Okay, now before we move on, how does that feel? Does everybody make sense out of that? Is that in your notes in front of you right now? You should have a big workspace like I have here, a lot of room. Is that making sense? Is that okay? What do you think? Okay, so then I say, all right, let me evaluate this. Okay, I want to evaluate that. So f prime of c. Oh, hey, what's up?
I need to.
Okay, go ahead. Yeah. F prime of c. See, just like you guys, got to go walk the halls. F of 5 is 2 minus f of 2 is 5 over 5 minus 2. So we're looking at -1. F prime of c must equal -1. And there's the answer. Okay, so let's take a look at the scoring guide just to try to understand it, because like I said, the scoring guide is on, I printed off, the PDF is up there on Schoology right now. And let me pull that up just so we could take a look at how it looks. Okay, I'm not saying this is the best formatting thing in the world, but okay, take a look at how the scoring guide looks. This is what's on Schoology now. All right, so it gives the problem, works out the problem. So here's 1 point. Okay, if you did, f of 5 minus f of 2 is 5 minus 2, over divided by 5 minus 2. Okay, so 1 point if you concluded, you set up the mean value theorem. Okay, and that's what it says. So I'm trying to see how it's written twice. Okay, so here's the mean value theorem guarantees as the value c with 2c. I don't know what that means. Okay, yeah, the formatting is not the best, but f of 5 minus f of 2 over 5 minus 2. And then did you use the mean value theorem? Did you set up everything in part of the mean value theorem? So that's what the scoring guide says. And so we did that. We did our preamble. We did everything that we're supposed to talk about. Okay? How does that look? That was number 1. We'll go to 14. Alex wanted to do 14. But is that okay for number 1? How do we feel there? Hey, Jimmy's here. Let's go to number 14. Okay. Take a look. On 14, 14 is saying we got the first derivative of the function, and it gave you the first derivative. Okay, how many critical values does it have on the interval between 0 and 10? Okay, now remember, this is with calculator. Okay, so find and tell me what a critical value is. I'm going to get my calculator ready to go. Tell me what a critical value is. Okay, what's a critical value? I need another computer screen. I'm bouncing too many computer screens. Deja, how you doing? Okay, a critical value is not where concavity changes. Okay, a critical point is where the first derivative is equal to 0 or undefined. Okay, so this is undefined, the first derivative. If you organized your binder, we used it on the first derivative test and the second derivative test. Okay, you're thinking of points of inflection, Eric, where it says the concavity changes. Points of inflection are where the concavity changes. So maybe organize some definitions, like we know concavity and points of inflection is second derivative stuff. Critical values, first derivative test, second derivative test, that's first derivative stuff. Okay, so where the first derivative is 0 or undefined. Okay, so I'm looking at my calculator here, and first thing I'm going to do is I'm going to go make sure I'm going to graph it. I'm going to double, triple check to make sure I graphed everything correctly. I got, it's cosine squared. Is that squared or cubed? Hold on, got to enlarge it, old man eyes. Cosine squared. Okay, cosine squared. Okay, so I got parentheses, cosine of x, close parentheses squared. So I got cosine squared. Now remember, you got to have the parentheses. Oops, see, I did it. Make sure you have the parentheses because you're squaring the cosine. Look how I entered that. It automatically puts an open parenthesis for the cosine. Okay, so have the cosine in parentheses and square outside of that. If you don't do that, you're just taking the cosine of xx, not cosine of x times cosine of x. And then we want to divide that by x. And then we'll go minus, 1/5. I'll just do 0.2. Okay, make sure you're entering that correctly on your calculator. This is the first derivative. So we're looking for where this is equal to 0 or undefined. I'm going to make sure my window's from 0 to 10 because that's what they were looking. And notice my y min and y max. I really don't care anything else that's going on. I care where it's between, where it hits 0. So I'm just going to make my y min and y max between 1 and -1. I graph it. Let's see what happens. And we're just counting. How many times does it equal 0 or undefined? Well, there's no undefined points except at 0, but that's open. Okay, that doesn't count. And so we look, we got 1, 2, 3, maybe. That's a maybe. So my choices are 1, 2, 3, maybe 4. Okay, let's double check that. Okay, because 3 and 4 are choices. Okay, so maybe we'll see, 3 or 4. I don't know. So let's zoom in around that point that we're worrying about. Now, what I could do, I just put a little box right there, zoom box, or zoom in, however you want to do it. Let me find my little cursor. Because the other ones I'm for sure. So I just put a little highlight, a little marquee around that. It's like click and dragging and seeing what it looks like right there. Just zoom box. And let's see if it does cross. Here it comes. Ah, it does not. You see that? Okay, so be careful of that. Okay, so what do you think the answer is then? If we feel good here, everybody good on the answer is 3. So make sure you, how we do there, make sure you really, it was hard to see there. Okay, but the definition, the key math word is critical value. And the critical value is where the first root is equal to 0 or undefined. 18. Let's go to 18. 18 is a free response problem, so let's work through the whole thing. The second derivative test, Eric's asking about what's the second derivative test. The second derivative test is for points of inflection. Oh, wait. Let's organize. It depends on, there's two different things we use the second derivative for. Okay? For maximums and minimums. Find your maximum and minimum page in your binder. Okay? To find maximums, first thing we set the first derivative equal to 0 or undefined. That's the first. Maximums and minimums occur where the first derivative is 0 or undefined. Okay, now we got a choice. Here's what your binder should look like. We got the first derivative test, or we got the second derivative test. Okay, the first derivative test says, and that's when we talk about the change. The first derivative says if the point changes from positive to negative or negative to positive. That's where we draw the number line. Here's our critical point right there. And we look at signs to the left and to the right. And if it changes from positive to negative or negative to positive, then we could tell whether it's a max or min. The second derivative test says just plug in that critical point into the second derivative. If you plug in the critical point in the second derivative and it's negative, notice that's concave down. So that critical point has to be a maximum. If it's positive, it's concave up, and that critical point has to be a minimum. That's the second derivative test. Okay, and your wording you go since f prime of x equals 0, or was undefined, whatever, and the second derivative at that point, whatever that critical point is positive, this must be a minimum. Or the second derivative is negative, this must be a maximum. Everybody look in your max and min section and see if that's there, because you got two choices. Now, when do we use each one of them? If you could pick points to the left and to the right, great. Use first derivative test. A lot of times you can't pick points to the left and the right. You're stuck right there. Only on that point is the only one you know. Like maybe they said the first derivative is equal to 0 and the second derivative is 12 at this point. You know, maybe that's the only one you know. So that's when you would use second derivative test. That makes sense, Eric? The other thing we use the second derivative for is points of inflection. And remember, points of inflection is where the second derivative changes from positive to negative. So that might be something else. All right, so let's go to 18. 18, a graphing calculator question. Okay, so we got a table of data here on 18. Okay, take a look. It says 19, number 19 we're doing. Okay, we got a number 19. Okay, we got a function. We got a table of data. Okay, it gives us the velocity. Okay, let me write it down here on the sheet. We got 0.3, 1.7, 2.8, and 4. Like I said, I can't print out the test for some reason. I can print some of them out. I don't know why I can't print this one out. 55 and 48 here. So table of data. So remember, as soon as we see data, we're looking for mean value theorem and extreme value theorem. Okay, we're looking for IVT and MVT. Okay? All right, so take a look. There's our data. And it says the velocity of a particle, P, moves along the x-axis. So it's given here where is measured in meters per second, and selected values of the velocity is given right there. So there's the velocity. Okay, why must there be a point where the derivative of velocity, the acceleration, is equal to 0? Okay, so again, what are we talking about here? Here's the velocity. And they're saying, why must there be a point where the derivative of velocity is equal to 0? What are we talking? Is that mean value theorem or intermediate value theorem? Okay, we're moving up a derivative. The derivative velocity, we're talking mean value theorem. You see that? We're saying mean value theorem right here. Because the derivative of velocity, moving up a derivative, we're talking mean value. We just did mean value theorem. So you say, why must there be a point? Okay, since velocity is both continuous. We wrote this already. And differentiable. We'll go quickly. By mean value theorem. Same thing. Same thing. Just reviewing it. That's why people asked about it. We're just reviewing it. Now, what points do we want? We want at 0.3 and 2.8. Okay, so we say v of 0.3 minus v of 2.8 over 0.3 minus 2.8 must equal v prime of, what letter they use in t, for some t, where t is between 0.3 and 2.8. That is just automatic. We just say that. That's when you want to use mean value theorem, that's what you say. Just like we did the last one. Okay, what did you notice here? Oh, look, that's 55 and that's 55. So that top, when I subtract those, that must be 0. Okay, so the prime of t must equal 0. Meters per hour per hour. Okay, let's go to B. B says use trapezoidal rule. Let's practice our trapezoidal rule here. Okay, use trapezoidal rule. We want 3 subintervals between 0 and 0.8. Okay, so if we're doing trapezoid, let me get a clean sheet of paper here. If we're doing trapezoid, remember each one always helps to go like this. There's your 3 intervals. Remember, visually, remember trapezoid, whatever trapezoid looks like. A trapezoid, this is base 1, this is base 2, this is the height. Okay? So notice the velocity, these are the bases. The heights are going to be the calculation for that. Okay, so for example, the first trapezoid, base 1 is 0 plus 55. The height is the distance. The height is 0.3. Don't think I'm using this 0.3. I'm using 0.3 minus 0 divided by 2. There's our first trapezoid. Okay? So remember, let's be proper about this. The integral from 0 to 2.8 of v of vp of t dt is approximately, show them your calculations. Let's do the next trapezoid. 55 plus negative 29 times the distance, 1.4, all over 2. We're doing trapezoids. You see that? And the next one is negative 29 plus 55. Oh, look, it's the same one. But the space is different, 1.1 all over 2. And that's going to equal whatever your calculator tells you that's equal. There's trapezoid rule. And how we doing? Is that good review? You should be looking at your binder on trapezoid rule. Is that a good idea? Okay, we're going to move on. So then it says a second particle is, now we got an equation. No more table of data. We got an equation. V of q. Find the interval during which the velocity of q is at least 60 meters per hour. Find the distance traveled during that time interval when the velocity is at least 60 meters per hour. Let's take a look at what they're saying there. Okay, this is part C. Okay, so we're using a new equation. Remember, this is with calculator. We're using a new equation. They get V of Q. V sub Q is equal to 45 square root of T cosine 0.063 T squared. There's V. Okay, there's that one. Find the interval during which the velocity is at least 60. Okay, so let's take a look at our calculator here. We got to get that into our calculator. We got 45 square root of x. Here, I should have cleared the calculator out. Hold on. Let's just start over again. I don't know where I'm typing. All right, 45 square root of x cosine. Now this square is on it, so 0.063 t squared. Close parenthesis for the cosine. Double check. 0.063. Yep, I got that right. I got t squared. I got square root. All right. And it says, okay, 0 to 4. So I go my window, My window's from 0 to 4. Okay, and this time it says when the velocity is at least 60 miles per hour, so I know we're going to 60 at least. So I'm going to go to, I don't know, maybe 100. Let's see what the graph looks like. So it goes up, and it looks like it comes back down. So let's do a horizontal line just to show at 60. And there's my horizontal line. So it wants, okay, so first question. Okay, find the interval during which the particle is at least 60 miles an hour. Okay, so if this is the graph, right there, that top part is where the particle is at least 60 miles per hour. Okay, at least 60 means equal to 60 or bigger. Okay, how do I find that? Okay, second intersect. And remember, just get close to the point and hit enter 3 times. And there's our first intersection. There's the first time. That's when it starts off. That's when t is 1.86618. Although, remember, what we do, we store that value right above on. So you can see that right above on. Okay, back to the home screen. Double check to make sure your x, that's the x that we're looking for, and you store that. I'm going to store that as a. Okay, so I'll call that a for myself. We're doing C. Okay, and we'll do the same thing. Did everybody follow that? Okay, we'll do the same thing for, back to the graph, find that point. Second calc, find the intersection, and let's move over to that part. Enter 3 times, and here's this other point, 3.5. The second part is 3.5191, blah, blah, blah. We're going to store that as B. So notice back to the same thing, same approach. Here's my X. Yep. Store that as B. Okay, so for answering the question, okay, find the time interval. Okay, so we say V of Q, VQ of T is greater than or equal to 60 between A and B. Since you identified A and B already, you could do that. Or you could just put between 1.866 and 3.519. All right? Approximate. Oh, sorry. What is find interval? Find the distance traveled. Okay? How do you find the distance? What's the formula for the distance? Okay, you should find that in your binder right now. If I have the velocity, how do I find the distance? Now remember, we spent some time for distance versus displacement. How do I find the distance between those 2 points? Okay, the displacement is the integral from A to B of V of Q, or VQ of T dt. That's the displacement. That's not what they're asking for. This is final minus initial. Remember, this is the position, I'll use S at Q of B minus the position of Q at A. This is fundamental theorem right there. That's the displacement. Okay, where is it at B minus where is it at A? That's the change. Remember, the integral is the change. What they want is the distance. They want the distance. So the distance, here it comes, the distance is the absolute value. Does that say in your binder? Okay, the distance is the absolute value right there, which I don't have a symbol for. I can't say fundamental theorem what this is equal to. It's not the absolute value of S minus the absolute value of S again. It's not that. It's whatever the calculator says it is. This is the total distance traveled. So I get my calculator, and I go, let me back to home screen. I am on the home screen. I go, and this is why we math, do the integral, function integral. We've done that before. And now this is why I did it, A to B. I don't have to type those things in again. A to B, and remember my velocity is under Y, but, hold on, let me get out of this. My velocity is Y, but don't forget, it's the absolute value. Okay, so math, number, there's where absolute value is. Or you could just use the submenu, the absolute value. of y1, and then I put an x right there. There is how you enter the absolute value. We've practiced that before, but this is what you say. And then now you just hit your enter, and it'll take a little bit, and it calculates the total distance traveled. Now, what's the units? 109. What's the units here? We're integrating velocity. It's distance, so it has to be just meters, because the velocity was meters per hour, so this is just meters. We're working our way backwards. How is that? That was C. Was that okay? We're doing 19 here, number 19. And let's go to D. Let's leave that up there. Remember, you could always pause the screen if you're watching this later. Let's go to D. Okay, D says at time 0, the position of Q is at, they're using X. When T equals 0, the position is negative 90. Okay, use the results found in part B and the function V of Q in part C. Approximate the distance between those two particles. Okay, so it's approximation. Now look what they're saying there. Look what we did on B. On B, we calculated the integral from 0 to 2.8 of V of P, V prime, or no, V of P dt. That's what we calculated. We approximated it, and we've, whatever value, I never got the value. Okay, let's get the value here. Whatever value we approximated it right there. Okay, whatever that number was, we could calculate that out. Now notice what it says. Okay, these are values, and it's moving up or down. Okay, and we'd like to find, okay, we would like to find the position. Like, where is it? Okay, because remember, this integral is the displacement. This result of this integral is the position the thing was at 2.8 minus the position it is at 0. Okay, and I'm looking at the problem. Let's see, did it tell us particle moves along the x-axis where VF is measured, selected values are shown. Okay, it never said where the position is. Oh, wait. No. Did it ever say where the Q is at? It tells us where Q is. Q is at negative 90. And we want to find the distance between P and Q. Now, hold on. We got to find, they have to tell us what the position of, can anybody see that? The velocity. They're giving us the velocity of the differential equation where V is measured in meters per hour. And we found the displacement. Okay, how far it moved. It said it started at the same. A second particle also moves along the axis of velocity. And find the time during the first. They should have given us the position of Q. They should have given us, let's check the answers here. They should have given us, maybe we're missing something here. They should have given us the position. I'm just going to pull the answers up here. At Q, take a look. Maybe I'm missing something here. Here we go. I don't know if you saw it. Let's move down. They should have given us, okay, see, we're going to integrate those. V of Q, okay, right, no problem there. Part D. The position of Q, the answer from part B. The position of the particle is there. Why is the position there? Oh, negative 90? No, that's Q. Why? Let's see if they said from part B, the position of the particle is here. Why is that? Did it say it's always increasing? Oh, maybe it said that. Let's see. Oh, there we go. All right, it says otherwise, there's a lot of reading here. The velocity of the particle with differential equation, measured in meters per second. All right, so if they're saying this, then they're telling us that the position is 0. It doesn't say anywhere. Oh, here we go. It's at the origin at time is equal to 0. So its position at 0 is 0. Okay, that's the part I missed. All right, back to work. Yeah, I was like, they had to tell us that somewhere. All right, so they said, okay, right, so here's the situation. Okay, this is the displacement. So this will get us the position at the position of P at 2.8 minus the position of P at 0, right? That's what we just talked about, the displacement. And the integral from 0 to 2.8 of V of Q of T dt will again get us the position of Q at 2.8 minus the position of Q at 0, right? That's the displacement. That's getting us where the position is. Okay? So now let's add it in. Okay, they said the position of particle P is 0 at 0, and the position here is at negative 90. Okay? That's what they're saying. So this is minus 8. Notice what this is. We could calculate this on the calculator. So we could find the position of Q at 2.8. And then we just calculated that on part B. And so we could find the position at P at 2.8. So this is what we calculated from part B. We'll enter that in there. And on part B, let's just quickly get the answer. Part B, this was, let me do a different color. This was from part B, you should have gotten 40.75. I don't want to calculate that. And now we'll just use our calculator like we just did to calculate this value. And this value is 135.937. Okay, is everybody seeing what we're doing here? So can you see how, using fundamental theorem here, we could get the position at P and the position at Q? Okay, so we just subtract that over there. And then we get the position at Q, position of Q, is 40, when I subtract that, 45.937. And from here, there's 0 there. The position at P is at 40.75. And there's a little subtraction there. The distance between them is 5.188. All right, let's make sure. Let's talk through this one more time here. All right. So first of all, we read the question. The question is saying, okay, it's saying, what is the difference, the distance between P and Q? So we want to find the position at P and the position at Q. That's the goal of the situation. Okay, so how do we find the position? We're given the velocity. How do we find the position? Okay, you have to integrate. The integral of velocity from 0 to 2.8 of velocity is the position at 2.8 minus the position at 0. That's the same thing on both of them. Just set up that integral. So notice this is what we're looking for. Well, this integral, we could do this on the calculator since they gave us the equation. We did this in part B using the trapezoid approximation. So those values we know. So then we were looking for these, and this is where I didn't see that the position at 0 was 0. It says it starts at the origin. So the position at 0 is 0. They specifically gave us the position of Q is negative 90. So we could plug those numbers in there. And then solving that, we get the position of each one of them. And what's the difference between them? That's what we got. How's that? Everybody see the situation? Okay, that's a tough one. There's a lot of thinking to do there, but when thinking about fundamental theorem. Anybody have a question on that problem? See, that's me pausing here. Anybody have a question? Everybody feels okay right there? Remember, nothing wrong with working through this again in 2, 3, 4 hours and then watching the video and making sure you did it correctly. And then what you'd have to do on the AP test is now your work here, and you'd upload that. You take a picture of that, and you'd upload it. And we're going to practice that once the program of what they're doing is coming out in a couple weeks, and we'll practice doing that. So don't worry about that part. All right, if no one's saying anything, here's what I want you to do. Now remember, tomorrow, okay, we'll come on again, tomorrow at 8:30 again, and ask more questions. Work through this some more. Okay, especially if you didn't get any, the ones you got wrong. I put it so you should, the scoring guide's on there, so you should be able to check your answers. If you can't understand what the scoring guide says, well, if that's fine, you say something to me. I say, we need to talk about that scoring guide. I don't get that. I don't know what it says on this problem, because that is kind of confusing there. So to work on this some more today. Tomorrow, we'll come on again, answer more questions. Okay, and then Monday, if we're all good, we'll have another assignment working on the ones that people said they got wrong. I got a whole list of stuff that we should work on. This ideas are mean value theorems, intermediate value theorems, mins and maxes, those kind of things. Here, how fundamental theorem of calculus is working right there. It's a little bit of everything. If we're good, then I think we're done for today. Don't we say anything? So I think we're good. So let's do this. Okay, let's have tomorrow. We'll meet you back again. I have not heard anything going on. Did that whole for you junior friends out there? There was going to be a practice SAT. That's not happening anymore. They can't orchestrate that, so don't worry about that. If your junior friends are saying something like that, don't worry about that. Look for something coming out in the next week about a survey for seniors about graduation. Okay, we'll see when that's going to run. Okay. If otherwise, send me an email. Now again, don't get one last little thing. Don't get all stressed out about working through these. This is just practice. We're just keep practicing, and you have your binder in front of you and practice for the next month. Practice as we're going to, remember, we got a month still to review, so don't worry about what's going on now. For the month, I want you to practice. I want you to always have your binder out. I want you to have your calculator ready to go, because that's where the test is going to be. And I'll notice how I'm assigning some more free response problems, and we'll keep going through those. Okay, and multiple choice are good to cover other topics. You got to try the work. I see a couple other people started it as we were working here. That's good. There's still 5 people that have not started it yet. Come on, get your work done. Okay, and then I will see you tomorrow, everybody. Have a good day.